Chapter 4, Section 4.1, Angles and Radian Measure. An angle is formed by two rays that have a common endpoint. One ray is called the initial side, and the other is called the terminal side. So here's an example here. We have an angle. We've got our initial side and our terminal side. Measuring angles using degrees. Angles are measured by determining the amount of rotation from the initial side to the terminal side. A complete rotation of the circle is 360 degrees. An acute angle is less than 90 degrees. A right angle is equal to 90 degrees. And an obtuse angle is more than 90 but less than 180. A straight angle measures 180 degrees. An angle that is drawn in standard position is when its vertex is at the origin of a rectangular coordinate system and the initial side lies on the positive x-axis. So first of all, a rectangular coordinate system is just the x and y axis. So we always start by drawing our initial side on the x-axis, and then we open up our angle, whatever degree measure we need, and then we end with our terminal side. If we have a negative angle, we start with our initial side on the x-axis, and then we open down. When we see an initial side and a terminal side in place, there are two kinds of rotations that could be generated. We could have a positive angle where we open counterclockwise, or we could have a negative angle where we're opening clockwise. An angle is called a quadrant angle if its terminal side lies on the x or y axis. So that would be anytime we've got an angle that is either 90 degrees or 180 degrees or 270 or 360 or any multiples of those. Coterminal angles are two angles with the same initial and terminal sides, but possibly different rotations. So what that means is we could have maybe a 30-degree angle. So that's about 30 degrees right there. We could also have another angle, so that one's in red, this one will be in green. We could have another angle that also has the initial side here, but this one opens up to here, which would be 390 degrees, 360 plus 30 more. So those are coterminal. Terminal means end, they end in the same place. Finding coterminal angles. So first of all, we're going to assume that the following angles are in standard position. Find a positive angle that is less than 360 that is coterminal with each. So back up to my drawing here, we just showed that coterminal angles are always one full rotation away. So they're always 360 degrees away. So we can take our angle, in this case it was 30, and we can add 360 to it. We can add 360 to it to a few times, and that's still a coterminal angle. We could also take 30 and we could subtract 360, however many times we want. That's still coterminal to 30. So here, we want to make sure we have a positive angle that's less than 360. So for 400, I could add 360 to it and I would get a coterminal angle, but it wouldn't be less than 360 like it's asking. So I'm going to subtract. So 40 degrees is coterminal with 400 degrees. Okay, negative 135 degrees. I can get a coterminal by adding or subtracting 360 as many times as I want to. They're all coterminal. But since I want a positive angle, I'm going to add 360. So then we get the angle 225 degrees. That's a positive angle, it's less than 360, and it's coterminal with negative 135 degrees. Measuring angles using radians. An angle whose vertex is at the center of the circle is called a central angle. Definition of a radian. We define a radian as the measure of the central angle of a circle that intercepts an arc that has equal length of the radius. So notice in my picture here, here's my radius of the circle. And this angle is equal to 1 radian because this arc length is equal to the radius of my circle. So that's how we define 1 radian. Conversions between degrees and radians. So we're going to use the basic relationship that pi radians is equal to 180 degrees. So first of all, to convert from degrees to radians, we're going to multiply our degrees by pi over 180. To convert from radians to degrees, we're going to multiply our radian by 180 over pi. So here we go, converting degrees to radians. So anytime we have a degree, we're going to multiply it by pi over 180 degrees. The way I memorize this is that I want to cancel out my degrees so that I end up with radians. So I put degrees on the bottom to cancel out. So here, 60 divided by 180, we're just going to get 3 on the bottom. So we get pi over 3. 270 degrees, same idea. We're going to multiply this by pi over 180. Again, I remember this because I want to cancel my degrees out. 270 and 180. I know I can divide both of those by 90. On the bottom, I would have 2, and on the top, I would have 3. And the pi is still on the top. Times pi over 180. I'm wanting to cancel out the degrees. That's why I know to put 180 on the bottom. I know I can divide both 300 and 180 by 60. So I'm going to end up with negative 5 pi on top and 3 on bottom. Converting from radians to degrees. So this time, I'm going to multiply by 180 over pi. I know that I want to cancel my pi's out because degrees don't have pi's in them. So that's why I put it on the bottom. And then 180 divided by 4 would be 45 degrees. So here we have negative 4 pi over 3. Again, we're going to do times 180 over pi. My pi's cancel out. Negative 240. And the last one, we've got 6 radians. So 6 over 1 times 180 over pi. Now this time, the 6 didn't have a pi with it. So since it doesn't have a pi, I know this answer is going to come out as a decimal. And that'll be okay. My math lab should tell you what to round to. Here I'm just going to round to the nearest whole degree, so 344 degrees. Finding coterminal angles. Now we're going to find coterminal angles out of radians. So first of all, we want to have a positive angle, and we want it to be less than 2 pi. Note that 2 pi is the same as 360, so 2 pi is all the way around the circle, so that's what we're going to be adding or subtracting. So we start with 13 pi over 5, and we're going to subtract off 2 pi. I need to make common denominators here, so I'm going to make that 10 pi over 5. So we get 3 pi over 5 is our answer. So 3 pi over 5 and 13 pi over 5 are coterminal. Now we've got negative pi over 15. This time I'm going to be adding 2 pi. Instead of writing it as 2 pi, I want to make it over 15. So I'm going to put 30 pi over 15. So we get 29 pi over 15 is our answer.